Hello, everybody, and I hope you guys all survived the first day online class experience. I think some of you might even like it because you have the video you can always go back to if you miss any information. So, like I say in my email, if you have any questions, don't hesitate, to send me an email, and then we can discuss it. So either I will answer your questions through email, or for some complicated questions, we may be able to open an online face-to-face chat. Okay. So today we're going to talk about is the section 7.4. Okay, and the section 7.4 is basically talk about the. Let me erase here. Okay, good. And so the sections, let me change this one. Okay. So we're going to talk about the section 7.4. Okay, where did that things go? Okay, here we go. Okay, so the section 7.4. We're going to talk some basic concept of probability. Okay, and so in this section, in fact, this sections is a pretty short sections here. So we're going to have to talk about the three rules. We called about the first one here, the unions rule, or sometimes we call this is the addition. We call this is the addition rule. And then the next things here we're going to talk about is a complement rule. Okay, and then the next ones here we're going to talk about this is the terms we heard all the time. We said odds, right? So what is the odds? If you say, hey, the odds for me to win is 3 to 5. So how do the odds transfer? Or you can say, how do the odds translate into the probability? So when you talk about the odds here, that's just another way you talk about the probabilities, right? Okay, so now let's go ahead and start, right? So this is what we're going to talk about in this videos here. Okay, so let's take a look at the first union rule. Okay, so let's talk about the union rule. Oh, we call this the additions. So here's the formula. You need to write it out, and so you might be able to use it later. So if we have A union B, and what is this one going to equal to? I'm going to demonstrate this by using the Venn diagram before I even write out the formula for you here, right? Okay, so I will say the events A is the red one, okay? And events B is the green one here. Oh boy, so here, okay. Oh, I erased both of them. That's not good. All right, so here. So this is the event A, is the red one, and the event B is the green ones here. Okay. So I want to find A union B. From the previous sections, we know the A union B basically is we want to find, if you still remember from the previous union, we say, hey, if this is your A and this is your B, so the A union B basically is we want to find these areas, right? So it's basically you combine the A and the B, see what is the value. Okay, so now let's take a look at these ones here, right? So A union B is here. How do I find it? Okay, so the first things I would say, how about I will use the probability of the A. Okay, so probability of the A, that means is this area, right? Okay, now I'm going to add probability of the B's here. Okay, so if you add the probability of the B, this will be the green areas here. As you can see, as you can see the center part, right? The center part, this area. So as you can see the center part, this area, this is the center part, right? This area has been added twice. You see the color red and the color greens, right? Had been added twice. But I know my A union B is here. So this is A, this is B. My A union B will just be this area. And I don't need to add the center part is twice. So now I know also from the previous sections here, we know this is A and B. So everybody still remember what is this part we call? The center part. What is this part? This is the common part, right? So this is the common part of A and B. So this area basically is A intersect B here. So like from here, I say if I use PA plus PB, then I know I added the center part twice. So in order to balance that out, I need to minus 1 out. So this is minus 1A intersect B. So after I minus 1 out, I only have, that's why I can get what I'm supposed to get is here, right? So I only count the inside once. I don't double count it. So this is what we call is the union rules here. It's a very, very important rules. And so make sure you understand what is the union rules means here, right? So this is what we call as a union rule. So when you try to add these two, so like if you want to find the probability of the A union B, it is the probability of the A plus probability of the B and the minus A intersect B. All right, so pretty clear, right? Okay, so now after that, I'm going to talk about then, I'm going to talk about the complement rule. Then after complement rule, we're going to find some examples here, right? So complement rule from the previous sections here, right? So from the previous sections, we say what is the probability of the A's here and the A primes here. So the A prime, or you can see probability of the A. What is how do we write here? So this is what. Let me use a Venn diagram also the same way. Probably will be easier, right? Okay, so in here, this is like I said, this is my A's here. So I know from the previous section, what is the A complement? A complement is everything what? Outside A's, right? So these green ones here, this is everything outside A. So the green ones here, this is what I call the A primes here, or we call it A complement. So in order to find the probability of A prime, I know the whole sample space. That means include everything, the whole sample space is 1. So I'm going to use 1 to minus the probability of the A. Is right? All right. And then what is the probability of A? If I want to find the area, A is this red area. If I want to find the probability of A, will just be the 1 minus probability of the A complement. So that means So that means, you know, if you add A and B together, so if you say the probability of A plus the probability of the A prime, this will be 1. Because why? Because when you add them together, the whole thing is a simple space. Simple space included all the possible outcomes. So that's why the simple space will be add up to 1. So this is the 2 very, very important rules for this section. And then for the next sections, we're going to talk about is the multiplication rule. So this section, we talk about these 2. We call it the union rules and the complement rules here. Okay, so now I'm going to go to the next page so that we can take a look at the problems here, right? Okay. So now here, let's take a look at the problems here. I'll start with the easy one, okay? So I'm going to say toss a die. Then I will say A is the event. So this is event, get a even number. And I want to say B, this is the event, get at least 3. Okay, so now I want to find, so if the problem say, hey, I want to find the A union B, I want to find the P A prime, I want to find the probability of the B prime. Okay, so let's take a look. How do we do this? So I toss a die. So first, let's write on the simple space. So the simple space here, I toss a die is 1, 2, 3, 4, 5, and 6, correct? All right. So now the event A, I said the event A is getting an even number. So what is the event A? Even number. So it's 2, 4, 6, right? Then the event B is here, we say at least 3. So that means 3, 4, 5, 6. Okay. So the, well, also let's try to find the A intersect B here. Okay. Okay, so first things here. So because total sample size is 6, right? So let's take a look. So what is my probability of the A will be? So probability of the A, we have 3 numbers over total 6. So the probability of the B, well, probability of A is 1/2. It's kind of common sense, right? To get a even number. So the same ways here, if you want to find the probability of the B, probability of the B, I have 4 out of the 6. So probability of the B is about is 2/3. Okay. Now let's take a look at A intersect B. Okay, so A intersect B is the common area, common part of an intersection. So which number is the common elements? This part, they both have it. Then 6 here, they both have it, right? So I know the A intersect B will just be 4 and 6. So the same way, then I can say the probability of the A intersect B is what? It's 2 elements out of the 6, so it's 1/3. Okay, so now let's take a look. How do I find the PA primes here? The PA prime is everything not A. So A is 1/2, right? So PA prime will just be 1 minus 1/2. So this is 1/2. Okay, so let's see PB hat. The PB, the B complement, B is 3, 4, 5, 6. Complement is everything not in the B. So it will be 1 minus 2/3, right? So it's 1/3. Okay, so now let's take a look at the P, the probability A union B. Okay, so if I want to use my additional formula, so remember my addition formula is PA plus PB, then minus PA intersect B's, right? So now the PA I know is 1/2, PB is here is 2/3, then A intersect B is minus 1/3. So let's take a look at what is this one here. So the common denominators is 6, right? Okay. And so this is the 6, and then this is the 3. And so I'm kind of find the common denominator. So this is the 4. This is a minus 2. So this is a 7 minus 2. So it's a 5, 6. Okay, so I know my probabilities here is 5/6 here. So now if you don't believe me, we can just manually do that to see what we have. So A union B, remember we talk about A union B is you combined, right? So you are kind of combined these two here, right? So when you combine these two, so you will see then you will have a 2, 3, 4, 5, 6. So you don't repeat. You know, like 4 and 6 is the same number, but you don't repeat that. So you see here, A union B have 5 elements out of the 6. So that's why the A union B is 5/6. Correct? Okay, so that's pretty cool. All right, so now let's take a look at the next example. It's a little bit tedious, not tedious, just a little bit more complicated here. So that is the example number 2 here. Now I'm doing a toss 2 dice. Okay, so let's toss 2 dice here. And let me see here. Okay, so the next example is a toss 2 dice. And now let's try to see N is the event. The sum is 7. And the B is the event. And so this is the event, got a pair, got a double. That means they are the same here, okay? And then let's see here, let's say here, C is the events, let me see here, the sum at least to be 10. Okay, so let's do this. So let's try to find the probability of the A prime, B prime, and the probability of the C prime. Then let's try to find the probability of the A intersect B, A intersect C, and the probability B intersect C here. Okay, so now the first things here we need to do is we need to write it out. Okay, let's also do the probability of A union B and the probability B union C. Wow, we have a lot of probability to do. So let's see here. So if I toss 2 dice, my sample space will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? Then here, this is a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then here, this is a 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. And 4, 1, 4, 2, 4, 4, oh, 4, 3, 4, 4, 4, 5, 4, 6. And I have a 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and the 5, 6. Now I also have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and the 6, 6, right? So I have a total, how many? I have a total, it's a 36 outcome. And every outcome has the equal chance to happen. Okay, now let's take a look at A. A, it says, is the sum is equal to 7, right? So I'm going to circle the A. So when you add the name is 7, so this is in A, this is in A, 3, 4 is in A, 4, 3 is in A, 5, 2 is in A, and the 6, 1 is in A. Right, so my red one, so this one's here, that's the event A. So I don't want to, kind of like write out again. So now we know the event A is here. How many elements we have? 1, 2, 3, 4, 5. So we have a total 6 out of the 36, right? So that's what is the probability of the A. So if you simplify that, it will give you 1/6. Right? So if you do that, then I know the probability of A prime. So remember, A prime is everything not A. So I have, how many? I have 30 is not A. So it's 30 out of 36. Or you can say this is 5, 6. Or you can just use the formula we say is 1 minus, right? So it's 5, 6. So it's the same way. Okay, now let's take a look at the probability of the B's here. The B, I'm going to use different colors. So B said, I got a double. Okay, so what do I mean, the double? So this is the B. So it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and the 6, 6. Oh, well, so the B, how many elements I have in the B? I have 6 also, right? So it's a double. So it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So the B is 36, and this is 1/6. So the probability of the B primes here will be how many? So it's total outside layer, right? So this is 30/36. So it's 5/6, right? So or you can use just 1/6, so it's 5/6 here. All right, so let's take a look at the C. C said at least 10. That means when you add them up, has to be a 10 or larger. So let's see, at least 10. So what is at least 10? So I'm going to have 5, 5, 4, 6, right? So it's blue one is my C, and the 5, 6, 6, 5, and the 6, 6 here, right? So how many is the C's here? So the C, I'm going to have 1, 2, 3, 4, 5. Oh, no. Do I have 6, 4 here? I forgot here. So this is at least 10, right? So 6, 4 here. Right, so 6, 4, 5, 5, 6, 4, 6, 5. Okay, so 1, 2, 3, 4, 5, 6. Aha. This one is also 6/36. So also is 1/2. So now the C prime is also 30/36. So this is 5/6. So, right? Oh, you can write it as 1/6 is 5/6. So 5/6 is, okay. Now let's take a look at A intersect B. Okay, so A intersect B is let me mark it. So the blue one, this is the C's, right? And the green one, this is the B's here. Okay, so now when we say here, A intersect B, so that's the common part of A and B. Do we find anything common with the red and the green? Oh no, so that's why we use this notation. We say, hey, this one here is an empty set. That means nothing there. If it's nothing, then that's why I know the A intersect B here is going to be what? The A intersect B here going to be 0, right? Okay, so now let's take a look at A intersect C here. A and C, that means the red and what? Red and blue. Did I have anything? No. Okay, so I don't have anything. So that means A intersect C is also the empty set. That means the probability A intersect C is 0 also. Then the next thing is here, let's take a look. B intersect C. Okay, B intersect C, that means the green one and the blue one. Ha, I find how many of there? Hey, I find this one and this one, right? So these two is B intersect C. They are the common part. So I know this is 2 out of 36. So probability of the B intersect C will be 2 out of the 36. I should say here is better. I said 2 elements, right? 2 elements. So this is 1 over 18. Okay, so now we got all this. Okay, so now let's take a look at these ones here. If I use the condition rules, right? So now let's take a look here. So like a probability of the A union B, remember we say the probability of the A plus the probability of the B minus probability the A intersect B. Hey, the A intersect B is equal to 0. So it's 1/6 plus 1/6. So it's 2/6. So it's 1/3. The same way, let's take a look at probability of the B union C, right? So the probability of B union C will be probability B plus probability C minus probability B intersect C. So B is 1/6 and the plus C is 1/6. What is the intersection? 1 over 18. Okay, so let's find a common denominator. So this is 3 plus 3 minus 1. So the probability of the A union is 5 out of the 18 here. Okay, so this is how do we find the additional rule and the complement rule. It's a pretty, it's kind of like the, as long as you have this type of problem, write out the simple space, then write out each element, then you just count it, okay? Okay, so the next thing, the last thing is pretty easy. So this is what we call about the odds. So what is the odds? Okay, so the odds here, so if I said here, so I will say, for example, if the odds, okay, favoring an event E, R, M to N. Then, because it's favoring, right? So then I know the probability of the E. So the odds are just like, then you just add them together. So because it's favoring, so you just say M plus N over the M. right? So what does that mean? So let's take a look at the examples here. If we play a game, so if you and me play a game, okay, if we play a game, the odds for me to win the game is 3 to 5. Okay, now let's not, okay, 3 to 5. So what is the probability I will win the game? So probability I will win. That means the odds here is 3 over 5. So it's 3 to 5. 3 out of the 3 versus 5 chance, 8 chances here. So the chance for me to win will just be 3. Then here is 3 plus 8. So it's 3 over 11, right? So because this is a chance I will win, so the probability I will lose will just be what? Right? So the probability I will lose will just be 8 of the 3 plus 8, right? So it's 8 over 11 here. That's what we means the odds. And the odds is pretty, like pretty easy to understand. So when you go to the casino, the odds here may be 1 in a million, right? So you will win. So that's why the probability you will win is 1 over 1 million plus 1. So it's quite small, right? So that's how do we define the odds. Okay, so that is the video for the section 7.4, and then you should be able to do your classwork and the homework after you watched these videos here. Okay, so I will talk to you for the next videos here. Okay, so remember, if you have any questions, don't hesitate to send me an email. Okay, bye-bye.